0.
0. This
1.
edge.
1. Oh, sorry, 2.
This edge.
2.
2. And this edge 0. Okay, actually I didn't need to calculate anything down here, because the initial costs are infinity. The initial cost there is 0. But let's just go through this formally. So total cost along this edge is 0 plus 1 is 1. Total cost along this edge is infinity plus 1, which is infinity. So this is clearly the survivor. Okay, into this node, infinity plus 0 is infinity. Infinity plus 2 is infinity. Actually, it doesn't matter. Let's not keep anything, because the cost into there is still infinity. That makes sense, because this is state 0, 1. The initial state is 0, 0. So the only, you can't get from state 0, 0 to state 0, 1 in one step, because the only two possible states I can have after state 0 are again state 0 or state 1, 0. So the cost into this state is still infinity. Okay, down here, cost along this edge, 0 plus 1 is 1. Infinity plus 1 is infinity. So this one is clearly the survivor. With cost 1. Here, infinity plus 2 is infinity. Infinity plus 0 is infinity. I'm not even going to keep anything. Cost into this node is infinity. And that makes sense also. It's impossible to go from state 0, 0 to state 1, 1 in a single step. Okay, now let's draw in the next trellis section. Okay, 1, 1. Along this edge, 2 errors. Along this edge, 0 errors. Along this edge, 0 errors. Along this edge, 2 errors. Along this edge, how many errors? Along here.
1.
1 error, correct. And actually it's the same for all the others. Okay, so this edge along here, I have 1 error plus 2 errors is 3. And along here I have infinity plus 0, which is infinity. So clearly this is the survivor. Into here I have 1 plus 1 is 2, and infinity plus 1, which is infinity, so clearly this is the survivor. Cost 2. Let me draw the cost here is 3. Into here, 1 plus 0 is 1. Infinity plus 2 is infinity, so clearly.
Sir, why are you considering, like, for each like section, we just only need to consider 2 states, right? We can ignore the rest. Because for example, like in this one, we can just consider the 0, 0 state. Yep. And 1, 0 state, right? The one that's infinity, like we don't even have to calculate that.
That's true. You could just skip ahead to that point, but only for these first 2 trellis sections. After this, it becomes non-trivial. So all I was doing is going through the whole general algorithm. Okay. This is the survivor into that state. Cost 1. Then here we have 1, 1. Total cost of 2, and infinity plus 1, which is infinity. So this is the survivor. Cost 2. Okay. So now, as you point out, we get into the first case where the costs into each state are non-zero, or excuse me, non-infinite. So therefore, each of these states is possible. Draw the next trellis section. many errors for following this edge?
3, like weight of error.
No, like just the edge, just the path metric.
0, 1.
1? This one?
1.
1. Same for these two. This edge?
2.
2. This one?
0.
0 and 0, 2. Okay. Which is the survivor into this state?
Either one.
No.
0.
I have 3 plus 1 is 4, or 2 plus 1 is 3. So therefore,
yeah.
2 plus 1 is 3, it must be this one. Into this state, I have 1 plus 2 is 3.
So both of them, so the bottom one will survive.
1 plus 2 is 3, 2 plus 0 is 2, so the bottom one must be the survivor. With weight 2. Into here, I have 3 plus 1 is 4, and 2 plus 1 is 3, so that must be, the 2 plus 1 is 3 must be the survivor. And the bottom one, I have 1 plus 0 is 1. 2 plus 2 is 4, so it must be that one. Total cost of 1. Next. Okay, errors 1, 1, 1, 1. How about for this edge? How many errors?
It's 2.
2, 0, 0, 2. Okay, survivor into here. 3 plus 1 is 4, 2 plus 1 is 3. Whoops, my bad. That's the survivor. This is not. Here I have 3 plus 2 is 5. 1 plus 0 is 1. Here I have 3 plus 1 is 4. 2 plus 1 is 3. And here I have 1 plus 2 is 3. 3 plus 0 is 3. Here I have my first tie. So when you have a tie, you can pick any rule you like to break the tie. Actually, well, yeah, you can pick any rule you like to break the tie. So let's just always pick the top edge of the two. Okay, so we can see, if you think back to what I did, I flipped the first bit. So therefore, by this point of the code, we should have only one error. So we should imagine that this is the correct trajectory of the code root. And you'll notice that this trajectory is already diverging pretty strongly from all the other paths. So over here, at 1 error, the other path metrics were 2 or 3. Here again, 2 or 3. Here, this is the only one with 1 error. The others are already at 3. So this is already a fairly good indication that this is probably the winner. Next stage. Errors here is 2, 0, 0, 2. How many errors along this edge?
1.
1. And same for these. Okay, so survivor into here. 3 plus 2 is 5. 1 plus 0 is 1.